Welcome to 1.1, which is order of operations and evaluating expressions. So we're going to start off with just a quick definition of absolute value. Absolute value means when you see the absolute value symbols, which are just straight up and down two lines with numbers or variables, numbers, letters in between. These just means the number or the value inside of the absolute value is the distance from zero. So the distance, and distance is always measured positively. Think about it as you're walking down the street or you're telling someone the distance from another place, like distance from home. You always talk about a positive number. Distance of value is away from zero. So distance from zero is always positive. So it's always a positive number. Oh. Always. So let's look at the first example here. The absolute value of negative 13. So well, how far is negative 13 from zero? That is 13 numbers away from zero. So absolute value of negative 13 is 13. So number two, absolute value of 21. How far is 21 from zero on the number line? It is 21 numbers away from zero. Now number three, we got to start thinking about this a little bit more. We got two different absolute values. So we start with the absolute values. We're going to treat those like they're parentheses, grouping symbols. So absolute value of 4, that's 4. The subtraction is not in an absolute value, so that will come down. And then we do the absolute value of negative 4. Absolute value of negative 4. Negative 4 is 4 away from 0. And now we're going to do the subtraction. 4 take away 4. 4 minus 4 is 0. So our answer here is 0. All right, with number 4, we have absolute value, but we have an operation in the middle. We have an operation of the subtraction, so we have to do that first. So inside of the grouping symbols absolute value, you have 15 minus 23. So you have a positive 15. Think about it like money. You have $15, you spend 23. Problem is, that means it's a negative. 15 minus 23. Another way I think of it is I think 23 minus 15 is 8. But when you switch it around, it'll become a negative 15. You're subtracting 23, taking more than there is. So it'll be absolute value of negative 8. And negative 8 is 8 away from 0. So positive 8. All right, we're looking at order of operations now. Order of operations, we have the acronym GEMDAS. G stands for the grouping symbols. These grouping symbols could look like brackets, parentheses, absolute value, and even they can be sneaky and be like square roots. Whatever's underneath will be included in on the grouping, or even like, you might not have ever seen it, but a cube root. Anything that looks like that is included in the grouping. E is for exponents. Let's do this in a different color. Exponents. So these exponents are like any power, any base to any number. The 2 is an exponent. X to the 5th power, that's an exponent. The 5 is the exponent. So anytime you have exponents, you got to take that base to the exponent and simplify it. So this is the order to simplify an expression. MD stands for multiplication and division. Well, let's do this in a different color. Multiplication / division. And you're going to work these out. Divide, we'll just put divide. You're going to work these out. If you ever see multiplication and division, you're going to work it out left to right. Always. So you just, like you're reading a book, left to right. And lastly is the A and S. This is going to be addition and subtraction. And again, we're going to work these out left to right. So if you have something like 10 minus 5 plus 2. You're going to do left to right. We have subtraction and addition left. You're going to do the subtraction first, then the addition. All right, let's do some examples here. So number 1, we look through it, what we have. We have a subtraction. We have an exponent. So subtraction, we have an exponent. We have division. We have addition. And we're looking at which one. We don't have any grouping symbols, so the G is out. Now I'm going to go to the next one, exponents. Do we have any exponents? Yes, we do. So we're going to simplify the exponents first. So we're going to bring everything else down. So 17. The subtracting, you're subtracting whatever 2 to the 5th is. 2 to the 5th means 2 times 2 times 2 times 2 times 2. You're more welcome to do this on the Desmos calculator. Let me pull that up. So 2 raised to, I'm hitting the A to the B to the 5th, and that's 32. Always try to do this in your head prior to putting it in the calculator. You're going to get much better at this math, like numbers, by doing that. All right, so the 2 to the 5th is done. We don't have any other exponents there. Next thing we have a subtraction, division, and addition. Multiplication, division. So we have, the next thing is multiplication, division. We have a division, so we got to do that. So we're going to you take the 32 divided by 4. That's going to be next. 32 divided by 4 is 8. So 32 divided by 4, and again, you can work that out on calculator if you want. So we have 17. 32 divided by 4 was 8 plus 6. And I'm going to just draw a little arrow to show that we're going to go where we're going to go next. So now we have multiplication, division, no more of that. We have addition and subtraction. And how do we work that out? Left to right. So we have subtraction and addition. So we're going to subtract first because we just work it left to right. So 17 minus 8 is 9. And then plus 6. 9 plus 6 is 15. And there's our final answer. All right, for number 2, looks like we have addition, division, and multiplication. 3 times 2, that's another sneaky way of saying multiplication, 3 times 2. We don't have any exponents, no grouping symbols. Well, we do have a grouping symbol, but that just means, grouping symbol means order of operations starts over on the inside. 2 is already simplified. There's no other like 5 times 2. There's nothing inside those grouping symbols. It's already simplified, so that's it. There's nothing else to do there with the grouping symbols. We have multiplication, addition, and division. So we are going to work multiplication, division, left to right. So looking at our multiplication, division, we have 54 divided by 3 first. So we got to do that. 54 divided by 3. Oh, that's a big one. Let's do that. Let's do that on the calculator. 54 divided by 3. 18. All right, that makes sense. 18. You hit a triple 18 on a dartboard. That's 54. Makes sense. So 18 and then times 2. You can put the little dot if you'd like for times. And now we have addition and multiplication. We still got to work out the multiplication. So 18 times 2. You can do that on Desmos if you'd like. 18 times 2 is 36. And 7 plus 36 is, so 4 and add 3 more is going to be 43. Cool. Number 3. Oh my goodness. So when it comes to division with a big fraction line, what you're going to do is you're going to treat the numerator, which is the top of the fraction, and the denominator separately at first. So I'm going to separate them out. So we're going to work these problems out separately. Look out the numerator, what I have highlighted there in, what is that, tan color. Grouping symbols, we have, see grouping symbols, 7 minus 2 to 2 squared. We're going to do start order of operations over there. So we have exponents inside of there. So let's look at 2 squared. 2 squared is 2 times 2, which is 4. So 7 minus 4 plus 17. And you can work out the denominator at the exact same time. Just think we're starting order of operations over there. So the gray highlighted, I have negative 14 plus 2 times 5, and that's going to be, we have multiplication and an addition. We are going to do multiplication first, so it'll be negative 14, 2 times 5 is 10. The numerator, keep working with that. We still have grouping symbols inside. We need to simplify. 7 minus 4 is 3. Once that, we don't need the parentheses there anymore. You can have them there if you'd like. You don't need them there. The only time you have parentheses you need them is when you have like a multiplication on the outside. There's really no need for them right at this point because we are just adding 17. You can keep them there if you'd like. If you want the parentheses, you can keep them there. Nothing wrong with that. And then the denominator, we have negative 14. Oh, I messed up. That should be a plus. Thank you for catching that. Negative 14 plus 10 is negative 4. 3 plus 17 on the numerator is 20. Whoa, that's not a 2. 20 divided by negative 4. Now, once you have the numerator and denominator both simplified, now we can actually simplify. I'm going to write that again. 20 divided by negative 4. Now we would actually do numerator and denominator. So 20 divided by negative 4 is negative 5. Positive divided by negative is negative. All right, number 4. Whew, this is a doozy. There's parentheses all over the place. So we do have grouping symbols. So let me talk about grouping symbols. So we have the first grouping symbol, and then there's a grouping symbol within. So remember, you're looking at the most outside grouping symbol. This is everything that's inside of the first bracket. Inside that, you always start order of operations over. So I'm thinking right now with the highlighted yellow, what's the order of operations? So I'm thinking grouping symbols again. Well, there is another grouping symbol inside. So I have to start there. That is where I'm going to start with my simplifying. So I have to do the 12 on the outside, bracket, 30. I'm just copying everything else down. So we do 9 plus 4 squared. Well, 4 squared is going to be the exponents first. So 4 squared is 16. 4 times 4. You're more welcome to use decimals if you'd like to figure that out. Over. And then in the denominator, if you want to work out that separate, you can work it together separately. It doesn't matter. But you just start over order of operations. It's its own problem. We need to simplify numerator and denominator separately. So you have absolute value of 10, and we have absolute value of negative 6. Those are grouping symbols. We need to simplify those. You can simplify them in the same step. So absolute value of 10, that means 10 away from 0 is 10. Minus from middle. Negative 6, absolute value of negative 6 is positive 6. Once you get the absolute value of something, you can drop the absolute value. You no longer are putting the absolute value symbols on there. Once you take the absolute value of the number inside, or the value of whatever it is. Now, it doesn't always have to be a number. All right, I'm going to continue to simplify this numerator. I didn't get rid of these parentheses yet. I still have 9 minus 16. I have to do that operation first before that parenthesis is simplified down completely. So I have 12 times 30. 9 minus 16 is a negative 7. I'm still going to keep it in parentheses. You don't actually need it in parentheses, but it looks kind of weird with a minus. You're subtracting a negative, and maybe you're already thinking, Mr. Johnson, that's just a plus. So you can change it to 30 plus 7 if you want at this point. And then in the denominator, we just have one more operation. 10 minus 6 is 4. And then looking at the numerator, we still got these. Still have 30 minus a negative 7. Two subtractions will actually switch it to a positive. So this really becomes... It's weird that I'm doing it in red, but it really becomes a plus. Minus a negative is, or you can think of it as the opposite of negative 7, which is plus, which would be a wonderful way of thinking about that. So this is the opposite of negative 7. Is another way to say it, subtraction. Opposite of a negative is plus. So you have 12 times 30 plus 7 is 37, divided by 4. Order of operations, we have multiplication in the numerator, 12 times 37. I don't have that many fingers, so we got to do this. I'm going to do this on Desmos. 12 times 37, 444. That's a Good number. I like it. 444 divided by 4. And if you take each one of those digits and divide by 4, you get ones. 111. Cool. And that is absolute value.